Imagine a train moving faster than a Formula One car at top speed. While Americans wait 3 hours delayed at Amtrak stations, Chinese passengers travel from Beijing to Shanghai, a distance of 1,300 kilometers, in just 3.5 hours. China built more high-speed rail in 10 years than Europe built in 50, and now their newest trains are pushing 400 kilometers per hour. Keep watching because you are about to discover how China built the largest and fastest rail network in human history, and why the rest of the world simply cannot keep up. Did you know that most countries still rely on rail infrastructure built 50 to 100 years ago? In the United States, there is not a single true high-speed rail line. The famous Acela train tops out at 240 kilometers per hour, but averages only 110. That is slower than driving on many highways. California has been trying to build high-speed rail between Los Angeles and San Francisco for over 2 decades. The project is billions over budget, decades behind schedule, and still nowhere close to completion. In Europe, the networks are fragmented, with different voltages, track gauges, and signaling systems making cross-border travel a logistical nightmare. A train from Paris to Berlin must switch electrical systems multiple times. Meanwhile, domestic flights create massive carbon emissions, and airports are choking with congestion. Traffic gridlock costs global economies over $1 trillion annually in lost productivity. Cities are suffocated. Commuters waste hours every day sitting in traffic or waiting for delayed trains. The mobility gap between modern China and the rest of the world is becoming a chasm that grows wider every single year. Here is what makes this even more remarkable. In 2008, China had virtually no high-speed rail. 0 kilometers, nothing. The entire network that exists today, over 45,000 kilometers of track, was built in less than 2 decades. To put that in perspective, Japan's famous Shinkansen, the bullet train that revolutionized rail travel in 1964, has only 3,000 kilometers of track after 60 years of operation. China built 15 times that amount in 1/3 of the time. If you laid China's high-speed rail track end to end, it would circle the entire planet more than once. That is the scale we are talking about. Every month, China adds more high-speed rail than most countries build in a decade. The 2008 Beijing Olympics became the catalyst for this transformation. National prestige demanded world-class infrastructure, and China's leaders saw an opportunity to leapfrog decades of development. They did not just want to catch up with Japan and Europe. They wanted to surpass them entirely. The master plan was called 8 vertical, 8 horizontal. 16 major corridors creating a spiderweb of high-speed rail across 9.6 million square kilometers. The goal was ambitious beyond anything attempted before. Put 95% of all cities with populations over 500,000 within high-speed rail access. Connect tropical Hainan Island in the south to frozen Harbin in the north. Link the manufacturing hubs of the coast to the resource-rich interior. This was not just transportation planning. This was nation-building on a scale never before attempted. Wang Mengshu, one of China's most celebrated tunnel engineers, spent 40 years working on rail projects before high-speed rail existed. When asked about this transformation, he said the young engineers today accomplish in 3 years what took his generation 30. The technology has advanced that dramatically, and the scale of ambition has grown to match. His words capture something profound about what China achieved. They did not just build faster trains. They compressed half a century of progress into a single decade. They turned civil engineering into an art form practiced at industrial scale. The crown jewel of this system is the CR-450, China's newest generation of bullet trains designed for 400 km/h commercial operation. During testing, these trains reached 453 km/h, fast enough to cover the length of a football field in less than 1 second. The precision required at these speeds is almost incomprehensible. A human blink takes about 300 milliseconds. In that time, the CR-450 travels 37 meters. Any engineering flaw, any vibration, any misalignment could prove catastrophic. Yet these trains run flawlessly, day after day, carrying millions of passengers in perfect safety. The aerodynamic nose of the CR-450 was tested in wind tunnels for over 5,000 hours. Engineers refined the shape until air resistance dropped by 22% compared to previous generations. The tracks themselves are engineering marvels that deserve their own recognition. Continuously welded rail eliminates the gaps between track sections that cause vibration at high speeds. Traditional rail has expansion joints every 25 meters. Chinese high-speed rail uses continuous welded sections stretching over 100 kilometers without a single gap. Slab track design, using concrete instead of traditional gravel ballast, provides a surface so smooth that passengers can balance a coin on edge while traveling at full speed. Every rail is aligned to within 0.5 millimeters. To understand how precise that is, a human hair is about 70 micrometers thick. The tolerance on these rails is roughly 7 times the width of a human hair, maintained across thousands of kilometers. Any greater deviation would cause dangerous oscillation at 400 kilometers per hour. The Beijing to Shanghai line alone stretches 1,318 kilometers and includes 244 bridges and 22 tunnels. Construction crews completed it in just 3 years. That is roughly 1 kilometer of finished track every single day, including bridges, tunnels, stations, and electrification systems. Workers installed over 1,800 kilometers of overhead power lines, carrying 25,000 volts. They laid more than 4 million concrete ties. They moved enough earth to fill 4,000 dump trucks. They poured enough concrete to build 20 Empire State Buildings. And they did it while maintaining tolerances measured in fractions of a millimeter. But that was the easy part. The Sichuan-Tibet Railway represents the most challenging engineering project in rail history. This 1,600-kilometer line crosses the roof of the world, climbing through the Himalayas, where the air is so thin that workers require oxygen tanks just to function. At 5,100 meters elevation, oxygen levels drop to just 50% of sea level. The route is 84% bridges and tunnels, because the terrain is simply too extreme for conventional track. Engineers faced conditions that seemed designed to defeat them. Underground rivers burst through tunnel walls unexpectedly. Rock formations proved unstable, collapsing without warning. Temperatures at high elevation dropped so severely that concrete would not cure properly. And all of this in a seismically active zone where earthquakes could strike at any moment. The solution required innovation at every step. Automated boring machines capable of adapting to changing rock conditions in real time. These machines can sense differences in rock hardness and adjust cutting pressure thousands of times per second. Concrete mixtures formulated specifically for extreme cold, using chemical additives that allow curing at temperatures 20 degrees below freezing. Bridge designs that can flex during earthquakes without collapsing. The Yarlung-Changpo Canyon crossing alone required spanning one of Earth's deepest gorges, over 500 meters deep, in a location accessible only by helicopter. Workers rappelled down cliff faces to drill anchor points. Helicopters made thousands of supply runs carrying equipment one piece at a time. Engineers redesigned critical systems multiple times when unexpected challenges emerged. When the first test sections opened, engineers checked their instruments 3 times. They could not believe the readings. The trains ran smoothly at full speed through terrain that many experts said could never support high-speed rail. The impossible had become routine. Today, China operates 45,000 kilometers of high-speed rail. That is more than the rest of the world combined. The target is 7,000 kilometers by 2035. Each train carries over 1,000 passengers, and the busiest lines move 150 million people annually. In a single year, the network transports 2.5 billion passengers. That is roughly equivalent to moving the entire population of Earth every 3 years. Guangzhou South Station, one of the network's major hubs, handles 500,000 passengers every single day. That is more than most airports handle in a week. The station covers 48,000 square meters, nearly equivalent to 85 football fields, with 28 platforms serving trains departing every few minutes during peak hours. During Chinese New Year, the network handles over 100 million trips in a single week. The Chinese train control system, known as CTCS, represents a technological achievement as impressive as the trains themselves. This proprietary signaling system allows trains traveling at 350 kilometers per hour to maintain headways of just 3 minutes. That means a second train can safely follow the first while both are moving faster than any commercial aircraft at takeoff. The system monitors every train on the network simultaneously, calculating positions, speeds, and trajectories thousands of times per second. If any anomaly is detected, automatic braking engages before human operators could even recognize a problem exists. When seismic sensors detect earthquake activity, trains within the affected zone stop automatically, often before passengers feel any shaking. The system processes over 10 billion data points daily. Maintenance happens with military precision. Every night, after the last passengers disembark, robots inspect the undercarriage of every train. Cameras and sensors scan wheels, axles, and brake systems for microscopic wear. Any component approaching replacement threshold is flagged automatically. Wheels are replaced every 3,000 kilometers. Every major system is overhauled on strict schedules that leave no room for unexpected failures. Over 4,000 maintenance workers patrol the tracks every single night, walking sections on foot with specialized equipment. This obsessive attention to detail explains why China's high-speed rail has maintained an almost perfect safety record despite moving billions of passengers. The impact on ordinary Chinese citizens has been revolutionary. Zhang Wei, a software engineer in Nanjing, commutes 300 kilometers to Shanghai for work 3 times per week. The journey takes 68 minutes each way. Before high-speed rail, this would have meant relocating his family or accepting a job he did not want. Now he has breakfast with his children, takes the train, works a full day in Shanghai, and is home for dinner. His story is not unusual. Millions of workers now commute distances that would be unthinkable in any other country. Surveys consistently show that high-speed rail is the #1 source of national pride for Chinese citizens after the military. They see it every day. They use it. They experience the future whenever they board a train. Cities along new high-speed lines have seen GDP growth of 20 to 30% within 5 years of connection. Real estate values near stations have doubled or tripled. Businesses that once served only local markets now sell products to customers 500 kilometers away, delivered the same day. The tourism industry has exploded as well. Destinations that once required overnight journeys are now accessible for day trips. Domestic tourism has tripled since 2008. Ancient cities that struggled economically are now thriving from weekend visitors. Families separated by distance reunite every weekend instead of only during holidays. The success has not gone unnoticed internationally. Indonesia opened its Chinese-built Jakarta to Bandung high-speed line in 2023, cutting a journey that took 3 hours by car down to just 40 minutes. Laos connected to China's network in 2021, transforming a landlocked nation into a transit corridor virtually overnight. A country with no previous rail experience now operates trains at 160 kilometers per hour through terrain that trucks struggled to cross. Thailand, Vietnam, and Malaysia are all in various stages of planning Chinese rail connections. Saudi Arabia has entered discussions for a Riyadh to Jeddah high-speed line using Chinese technology. Serbia and Hungary are building a Chinese-designed route connecting Budapest and Belgrade. Across Africa, China is offering rail agreements that could reshape the transportation map of 1.4 billion people. The new Silk Road runs on rails, not camels. Nations that connect to this network gain access to the world's largest manufacturing economy. Nations that remain outside watch their competitive advantages slowly disappear. The manufacturing advantage is overwhelming. CRRC, China's state rail company, produces over 200 high-speed train sets annually. That is more than the entire European output combined. Their factories have achieved economies of scale that make competition almost impossible. A Chinese high-speed train costs roughly half what a European equivalent would cost, and delivery times are measured in months rather than years. The CR450 is expected to enter commercial service on the Beijing to Shanghai corridor in 2025, making it the fastest scheduled rail service on Earth. The journey time will drop below 3 hours. Passengers will travel faster than any train has ever carried commercial travelers on a regular schedule. But engineers are already looking beyond. Maglev technology using magnetic levitation instead of wheels could push speeds past 600 kilometers per hour. A prototype maglev train reached 623 kilometers per hour during testing, faster than a commercial jet at cruising altitude. Shanghai already operates a commercial maglev line to its airport, giving passengers a taste of what the future holds. Plans extend beyond China's borders as well. Lines are planned to Singapore through Laos and Thailand, creating a continuous high-speed corridor of over 3,000 kilometers. Engineers have studied routes to Europe via Kazakhstan and Russia. The vision is seamless travel from London to Singapore, entirely by Chinese-built rail, financed by Chinese banks, operating on Chinese technology. This is not just about transportation. This is about reshaping global trade routes for the next century. What China has accomplished with high-speed rail is nothing less than the greatest infrastructure achievement in human history. In under 2 decades, they built a network that moves 2.5 billion passengers annually at speeds the rest of the world can only dream about. They conquered mountains thought impassable. They connected cities that seemed too remote. They created jobs for millions and transformed entire regional economies. They proved that with sufficient ambition and coordination, Humanity can accomplish things that previous generations would have considered impossible. So what do you think? Could high-speed rail transform your country the way it has transformed China? Would you ride at 400 kilometers per hour? Leave a comment below and share your thoughts so we can discuss together. And do not forget to subscribe right here, so you do not miss more incredible stories about how engineering and ambition are reshaping our world.